Okay, everybody's heard about the great news that Careem successfully sold to Uber about 2 weeks ago now. It's an amazing accomplishment for a regional startup. $3.1 billion, it's unbelievable, correct? So, very happy to have Abedulazez Kasaji with us. He is the product manager for the machine learning department at Careem. He works as part of the data and AI team. Abedulazez has been working in the field for quite a long time. He started off with a startup called Molna, which was acqui-hired by N2V back in the day. And then he moved on to Imena Group, and he worked on projects for the Saudi ministry, or multiple Saudi ministries in the Saudi government, things like IKEA, KSA, even many other projects. Today he manages Yoda, which is the in-house machine learning platform for Careem. And I think he has a lot of great things to actually tell us. So please, a warm welcome for Abedulazez.
Thank you so much. يعطيكم العافية. So my name is Abed. I work with Careem at the data and AI team. So I'm very happy to be here today. Thank you for making the time. Thank you for the organizers as well. Today I'm gonna try to tell you our story of how we built machine learning and scaled machine learning, and I hope this will inspire you in your journey in software development and machine learning. I'm really excited and proud to represent a lot of my colleagues who did an amazing work on this, whether like the news that was just mentioned or generally in the AI space. So before we start, who is Careem? Like, who are we? What is Careem? I think now a lot of people know Careem. Almost everyone knows Careem now after the news, but it wasn't an overnight success. Careem started back in 2012 by our two co-founders, who were followed by a third co-founder after that. And they wanted to build something meaningful and big for the region. What they actually started with was a simple transportation, like ground transportation solution for businesses. So this is what actually Careem started with, and for a few years, Careem was only that. And it picked up after a short while. When we started, we had no tech. It was manual dispatching. Our co-founders would call captains and just tell them, okay, can you pick up this customer from this place to this place tomorrow at 4 p.m., and something like that. We had manual navigation, manual payment processing, manual everything. I'm telling you this because a lot of people consider Careem started, basically what we have today, we started very agile and we built all the way through this. But what we had from day one is our mission. And our mission is to simplify the lives of people and build an awesome organization that inspires. So where are we now? We're in 15 countries, 120 cities. We have amazing 3,500 colleagues that are aligned to this mission. We have more than 33 million customers, and we have 1 million captains. I think more than 1 million captains. We have expanded into multiple verticals. We have mobility, delivery, and payment. And even in the ride-hailing space, we have expanded to buses in Egypt, soon in other countries, hopefully. We also have the food delivery that started in UAE and Saudi. And we have peer-to-peer payment, which is our first MVP towards Careem Pay, which is our digital wallet. While building those pieces and basically expanding to different verticals, we realized that not only we built Careem as a ride-hailing company and those verticals, we actually built a platform that we started leveraging to even other partners to use our platform. We realized that we built a payment processing across the region from Pakistan to Morocco. We realized that we have the SMS, we have the email gateways, we have a lot of components that startups don't necessarily have to build. So with Careem today, we're positioning ourselves as the leading technology of the leading technology platform of the region. And the topic of today is basically building and scaling machine learning. And to be honest, I'm going to tell you a few examples that without machine learning, we couldn't actually do them in the classical development way. And once you talk about AI and machine learning, what do you think about? Basically, what is the seed for machine learning and AI? It's the data. And at Careem, Okay. And at Careem, we have a lot of data that comes with its own challenges. At Careem, we process terabytes of data that is being generated by our systems, or basically the trips that the customers take on our platform, the traffic of certain streets. We have a lot of structured and unstructured data. Unstructured data like the data that is being used by our call center agents and basically the support tickets that we receive. And not only that the massive amount of data is one challenge, it's basically the nature of the data and the nature of the problems that we're solving. If you think about machine learning in the digital space, it's mostly, think about the ads example. It's mostly you're trying to predict if the customer is going to click on this ad, if this customer is going to like this post or something. But with Careem, it's basically real-time physical world. What we're dealing with is captains who are driving on the road, customers trying to get from point A to point B. What I'm going to start with now is basically as examples, so a few examples of the AI use cases that we use at Careem. And I'm going to start with the marketplace. So as you know, Careem, the ride-hailing business, is a marketplace. We have supply, we have demand, we have the captains, and we have the customers. And what we're trying to do is to have a healthy relationship in this marketplace where captains can earn money and customers can get to between points A and B and get there safely, right? So it's super critical for us to optimize our marketplace. And again, basically, when we talk about the classical ways of building a marketplace, the classical way of understanding the marketplace, understanding the nature of each one of our cities that we operate in, it's super critical to build it without machine learning. The examples that I'm going to talk about is basically one, the ability to predict demand and supply. Essentially, we use that for peak and dynamic pricing. I know a lot of you might like peak a lot, so when you see it in the app, we use it to plan ahead when we dispatch. So basically, just to be able to move the supply properly, where we predict that there's going to be demand maybe later in the day or later in the week. Ability to accurately to fulfill the promise for our customers, like ETA, the expected time of arrival, and the prices. So basically the fare estimate that you see in the app, and the ability to predict and understand the customer and captain behaviors. How likely is this captain is going to cancel this trip? How likely this customer is going to cancel this trip? How likely is this captain will actually accept this booking, right? So it's a lot of predictions, and that feeds into our dispatching systems. And also to plan ahead and understand what are the trends in a specific city. This helps us a lot in our long-term marketplace strategy. So I'm going to start with a very simple example that we process, I think, millions of times every day, which is matching customers and captains. And for people who don't know like the complexity of the systems that are like used to build a dispatching and matching system, it's super simple. Like a lot of people tell me, why don't you just give me the nearest captain to me, right? And I think it's a lot more complicated than that, and I hope I can illustrate that. So let's hypothetically assume that we have one customer and one captain, and this customer tabs Yalla. We just simply match this customer with this captain. There is no logic here. What if we have two customers and one captain? One customer is 6 minutes away, while the other is 8 minutes away. You might say, okay, because we want to make our marketplace as efficient as possible, let it go to the 6 minutes, basically to Mariam. But what if Mariam is very likely to cancel the trip? What if the probability of cancellation for Mariam is 0.8, while the probability for Rashid is 0.1? So things change very dynamically in this case. Let's take it another level. What if Mariam is going to downtown, which is basically a relatively higher demand area than Jabal Ali, where Rashid is going, which is like a bit of a remote area? Then all of these decisions we take real time, millions of times every day. And to tell you what are we doing basically for the cancellation problem, it's a simple binary classification problem where we predict that this booking will end and basically dispatch based on that. The features involved in such a model are a lot. So we have a lot of contextual features, and features in the machine learning context are the attributes that we use to train the model. We use as inputs to train and basically predict data based on that model. So we have a lot of contextual features: what time of the day, what day of the week, the city, the zone, the weather conditions. We have a lot of booking-related features, like if this trip is cash or credit card, if this trip has peak, and what is the expected time of arrival. We also have a lot of features related to the customers and captains, the cancellation rate for the user, if this user cancels a lot, or the cancellation rate for the captain, and even the average ETA for the cancellation for the customer to understand the sensitivity. Right? So for some customers, they might be okay with 5 minutes, some customers might be okay with 10 minutes. This is something that we aggregate and understand based on the customer level. Another use case that we use in our marketplace in the machine learning space is basically demand prediction. So this is Cairo. On the right, you see a prediction for the full week. And this is, I believe this is booking sessions. So basically, people who are tapping Yalla. And this is the reality after 1 week of that prediction. And the accuracy is, I believe, was around 96%. So why do we use this? One practical example of how we use this data is making sure that we have the right captains, ensuring that we have supply for such demand. The examples of that, basically, if we know that on Friday, Friday morning, we have we don't have enough captains. So what we do is we try to acquire those captains. We try to give certain bonuses and guarantees just to make sure we have a balanced marketplace on that day. Other examples, I think most of you have seen this one, which is the drop-off prediction. So we help you in entering your drop-off location, basically based on prediction. And this was recently featured on the Cat Boost website because we actually use their technology. And this is a graph of our time series forecasting. The yellow or the orange is basically the future, and the green is the history, and the black is the validation. As you can see, there's a lot of examples in the marketplace, and those are only a handful of those. Another area where we use machine learning heavily is platform integrity. And platform integrity means fraud prevention, security, and quality. Mostly fraud prevention saves a lot of money, millions of dollars every month for Careem. And the technologies that we use is supervised learning. I think this was mentioned yesterday also. NLP, natural language processing. We use a lot of graph anomaly detection. I'm going to show you a very nice graph now. And deep learning technology. Examples of the cases I'm going to walk you through. A trip outcome prediction. We predict if this trip is going to end up with a payment. A captain quality assurance, anomaly detection, and captain groups. So trip outcome prediction is also a classification problem. As you know, in most of our cities, we have the cash option enabled, so you can pay your captain with cash. And in some of the cities, we have higher fraud cases where customers don't end up paying to the captain. So what we built a lot of models that were trained on each city of those to understand what nature of customers are going to not pay, so we prevent that booking from even happening. So if you have a good booking, we predict that you will pay, we'll let the booking go. If we predict you will underpay, or maybe underpay today, but you can pay it tomorrow, then we allow you. If not, we just block the booking. Another case that we use for fraud prevention and detection. So as you know, there is or as you might know, there is an incentive for our captains to pick up certain bookings from certain areas. Let's say airport, because they get an additional reward. Or they want to fake their location to be in a mall where they can actually get more bookings. So on the left, you see a real trip ping pattern, and this is the ping data that we collect from the captain device. And on the right, there is the mock location. Any human can detect that, right? But the challenge is how can we automate this process and understand how we can prevent and block certain captains who are using those mock locations. What we do is we do the feature extraction based on the data that we get from ping data and snap to road data to understand if they're actually moving on the road or they're just flying inside buildings. And we have something we call Sherlock DB, Sherlock as in Sherlock Holmes. It has a lot of aggregated features on fraud, related to fraud. The feature extraction happens, and then we train the models, and basically we end up with identifying the fraudulent captains. Another very, very interesting case that we recently deployed was basically captain fraud, but in a very unique way. So what used to happen is that captains used to have two phones, let's say, and then they would make a fake booking from phone A to their phone B, which is a captain, right? So we used to detect that by looking at the percentage of bookings for this customer. If, let's say, 100% or 80% of this customer's trips are with this captain, then this is actually very likely to be a fraud case, right? But then what used to happen is that few captains used to sit in a car, 4 of them, and then they would share different customers. So they would share it for like few trips, and what would happen is that we would look at the customer and see the customer only did 20% with this captain, 20% with that captain, 20% with that captain, and we would feel it's fine, but there is fraud. And most of these captains were actually just only doing fraud trips. The red circles are actually the captains, and the yellow ones represent customers. So as you can see, there's a lot of shared customers between, let's say, the one on the right and the one on the middle. And that doesn't actually happen in real life. So this is another way of how machine learning can actually help us in detecting fraud. And something, again, as a human, you can detect that, right? But the challenge is how you make that automated through machine learning and basically take those decisions on your behalf. Now to the next point, which is basically our challenges with building this. A lot of you might be excited now about data science and machine learning, whether you're like, you want to do it yourself or you want to hire data scientists in your company. And the perception is that you will join a company, 80% of your time will be writing machine learning magic, right? So you would like to believe that you are a magician, you're like solving these amazing, exciting problems, again, playing Sherlock as the fraud team does. You understand that getting the data, training the model, deploying the model is there, but it's only a small subset of your time. Unfortunately, this is not the case. This is a paper that was recently published in NEPS by a few Google researchers. And what it says is actually in real-world applications, machine learning code is only a subset of the whole system that actually runs this. And the challenge lies inside the data collection, the feature extraction. Some of it, the data scientist is trained to do it, and some of it, the data scientist is not trained to do it. And then they get stuck. They would need help from data engineers, back-end engineers, data analysts. They need to understand what kind of resources they need, what is the machine that they want, that they need to actually train their model, what is the serving infrastructure, and how to monitor that once you deploy it in the real life, in the real world, right? And at Careem, we also have a lot of challenges related to Careem. As I mentioned, so what we have today is we need to, for our scale, we need to tweak and develop hundreds of models. And basically having that flow where we need a data scientist per model or like per 2 models it's not gonna work with us. The second challenge with us is that we have a lot of dimensions. And dimensions could mean cities or customer card types or gender of the customer, whatever the data scientist can use. But let me give you an example, and I think this is what I mentioned before, basically in the fraud cases. If we detect that a fraud pattern is ABC in Karachi, we cannot just take that and apply it in Amman or Cairo, right? So we need to train the model for every city, for every case, for every city, or for every dimension. Something that works for, let's say, economy car type might not work for pooling or might not work for business, right? So this adds another layer of complexity on the data scientists that they need to do this work repeatedly many times. Our production systems are quite complex. We need very fast response times. Usually, we aim to do it less than 30 milliseconds. Because think about it, when you open the app, you want to book a ride, you can't wait for like a few seconds just to know if you're a fraud customer or not. We can't show you, just wait please until we verify your account. It needs to be super, super fast. Another thing is that some of our models require some external data. And this adds another complexity where the data scientists need to integrate the service, which is outside of Careem, into this model. And lastly, we need very tight monitoring and alerting for training and serving as well. So our solution was building Yoda. And maybe some of you might know Yoda from Star Wars. It's the green little guy, super wise, and basically he's our mascot at our team. So our mission as Yoda team is to accelerate the adoption of AI across the company. Because if it's going to be super challenging to work on your model, to develop your model and release your models, then practically no one's going to do it, right? So our mission is to make it super easy and super simplified, that we just accelerate the adoption of AI across Careem by empowering the data scientist. So what we built is a full automation of the cycle of machine learning, starting from fetching the data, extracting the data, processing the data, on the feature engineering side, building the model itself, suggesting which kind of like algos to use, hyperparameter optimization, and lastly, which is to be honest, the most challenging step, to deploy your model to production, right? So what we have today is something called one-click deployment, that within couple of hours, you can deploy your model to production, and then you can start seeing real data. So this is quite dense. I'm not sure if you can read it, but to be honest, it was just to illustrate a lot of features that we have built inside Yoda to serve data scientists on different steps. So when it comes to generating data set, we have provided them with a UI that basically knows where is the data stored, and basically is connected to the lakes, to the data warehouse as well. And this can be scheduled through UI. We also started something last quarter, Farabi DB, which is our feature store. And Farabi is a scientist who translated the work of many scientists and made it available to many more, and we hope that this feature store will do the same. So if any data scientist develops a certain feature or aggregation, they add it to this feature store for others to utilize and use and make their work a lot more faster. On building the models, we have automatic model selection and tuning, as I mentioned. We have the hyperparameter optimization. We have scalable training on the cloud. So if your machine, if you want to train something that is not possible within your machine, you can actually train it on the cloud. And also, something that we recently developed is the integration with Jupyter Notebook. So Jupyter Notebook, a lot of data scientists, are you guys familiar with Jupyter Notebook? Awesome. So basically, it's the most favorite tool for data scientists. They can't live without it. And honestly, a lot of them didn't use Yoda before we had the Jupyter Notebook. It was a great motive for them to start using it. So we integrated our work inside Jupyter Notebook. So it's kind of becomes more invisible with time. Evaluating the models, once your model is trained, whenever there is a scheduled retraining, you get a Slack notification that your model just got retrained. Whenever there's a problem with your model, your model is not performing as you want, or basically reaches a certain threshold, you receive a Slack notification. We have a lot of plots that basically are shown to you once you train your model, just to help you make a better decision. We have a lot of features like standardized benchmarking dataset. So even if you train your model after 1 month, you want to test your model against different datasets. So this is also available out of the box using Yoda. Lastly, as I mentioned, deploying models on production, which is the one-click deployment I just mentioned. Within few hours, you deploy your service. You can consume it. It's fully monitored and with alerting, with everything. So this takes a lot of effort that before existed for our data scientists. And it's already integrated with our in-house platforms, like A/B testing platform, or like the monitoring tools that we use, etc. So it's within Careem's ecosystem. So this is a summary. Again, I'm not sure if it's very crisp, the font. So this illustrates the dataset generation part, where we get this data from different sources, training, serving, where serving actually can take different data points like the APIs I just mentioned, or some features that we need on real-time basis. Let's say we're predicting something related to restaurants, so we want to know how many orders the restaurant received in the last 15 minutes. Right? So we fetch some data on real time, and this is all basically connected to the client service, where the client sends an input data, and we reply with a prediction. It's all logged and it's all monitored and connected to alerting. This is a little bit about the system architecture and the libraries that we have and the integrations we have. As you can see, there's Yoda UI and then the command line interface. Yoda UI is a website. It's like a web page you can use, as well as the notebook I just mentioned. You have the management API. We are integrated with a lot of like the famous libraries like scikit-learn, CatBoost, TensorFlow. And all of our pipelines are basically scheduled. You can schedule that with Airflow very easily. And this is a page you get when you train your model. So this is the model report. You get the ROC curve. You get the confusion matrix. You get a lot of details that probably you can't see as well, like how many resources were used, who is the owner of the model itself. And this is a sample of the Slack notification you get when you train your model. And I think, yes. So what's next? As of today, we're working on FarabiDB, as I mentioned. We also started working on AutoML, which is drag and drop prediction, which allows everyone, not only data scientists, anyone at Careem, we want them to be able to extract value from machine learning and AI. Let's say we sent a promo code to 1 million users. Those users used it, those users did not. You just take this data set, drag drop to a web page, and then basically you get the prediction. You train the model, and then if you have another, if you want to have another campaign, you use the prediction. So step by step, we go to more AI-driven company. A finance team can use it as well. We're building a lot of apps on top of Yoda. Yoda is our general platform machine learning. We're building a time series forecasting platform. This is going to be separate. As I showed you now, it's inside Yoda, but with time, we're going to separate it outside and add a lot of more features to that. Anomaly detection, NLP, and sentiment analysis will have different functionalities and platform, a specialized platform for every vertical that we have. And I think that's it. Thank you.
All right, Abed, thank you very much. Thank you, merci, تشكر لا, شكرا, شكرا, whatever. All right, well, as Yoda would say, presentation interesting that was. Now we have a few minutes for questions, and we have one in the back. Please stand up. But by the time we get the mic up there, I'd love to hear more about some of the insights that you're finding now in machine learning. What can you tell about customers? I know recently in the app, you started asking for more fields. At least that's what I saw. For example, your gender and your birthday and all that different stuff. And Careem is kind of trying to build a super app where you have multiple things in that one location. What can you tell us more about your interesting findings about things that perhaps are not obvious to users about who they are, what their demographics are, for example?
So again, I think for Careem, for us, it always goes back to the mission, which is simplifying the lives of people. And whatever data we believe we lack and we need to, in order to make your life simpler, to make your experience simpler at Careem, to recommend certain, like connecting that to the super app concept, to recommend certain dishes for you based on whatever data that we don't have. We actively collect that data to serve you. On the super app point, what we realized also this region, we don't have a lot of, we lack a lot of the fundamental apps in the West. And this is something that has been replicated a lot in the Eastern world, right? When you go to Southeast Asia or you go to China, you find a lot of super app examples. So what we're trying to do is to experiment that, and hopefully we'll MVP something soon that would also simplify the lives of people.
So following the WeChats of the world, for example.
More or less.
Excellent. Okay. The question.
مرحبا يعطيك العافية. Are you planning
يعطيك
to open
العافية is
source?
not the right word now.
Okay. Are you planning to open source any of these tools you are working on?
So actually we had that in that slide that we wanted to open source this. Again, I think now we cannot commit to anything, especially that maybe our roadmap will shift a little bit. But obviously we'll outsource whatever non-core components that we have. Hopefully maybe the Farabi DB definitely might be a good candidate for us to outsource. If you stay in touch, hopefully I can keep you posted.
Another question? Here.
Thank you so much for the talk. I was always inspired by the things you do, guys, to make things great at Careem. As we know, like if you have like a model with 96% accuracy to solve problem X, it won't remain accurate for over the time. So as you're experiencing more new cases and all the stuff, so how do you manage to get that? Do you prefer like a sort of online learning where you inject automatically online the data you're getting new, or you prefer to do it like in a separate flow to write and test and monitor such new cases and build a new model and deploy it again?
That's a very good question. I think I mentioned that in my slides, but maybe I didn't read through it. What we have today is a basic drift detection mechanism, right? And drift detection means that if your model is not performing as per your exact requirement, then you'll get an alert, maybe to retrain the model, maybe to add more features, maybe to do something different. But I think it goes back to the use case. For fraud, obviously, when you launch a fraud model, it will capture a lot of fraudsters, but then the fraudster would evolve to do something different, similar to the case that I just mentioned. And then you need to keep training your models. You need to keep tweaking your models. So it depends on the use case, but what we have today is a basic functionality of drift detection, where you as a machine learning developer or a data scientist, the model owner, you get notified when your model is not performing as per your accuracy. And then at the end of the day, accuracy, even for certain cases, you need 99.9999. For some cases, you need 70%. So it depends on how critical your model or how critical is your use case.
Excellent. Another question we have over there. Right there. Would you stand up, please?
Thank you. Hi, my name is Arish. I'm a hardcore user of Careem. First, you indicated using AI for customers and your captains. But my question is about one of the core assets that you use in Careem, which is the maps, which will give me a better user experience. Sometimes I have to guide the captain to a better route, and sometimes the map gives me the best route. Do you have any vision of making something that can memorize the route that I picked or anything like that? Because that will enhance my user experience.
Amazing. And honestly, this is one of the things we wanted to build maybe like 2 years back when we said what loyal customers actually want. They wanted a fixed route. They wanted to say, I don't want to guide the captain every day. I have a preferred route. I want to do that. Unfortunately, it's not, as per my knowledge, not on the roadmap as of today, but this is a good input. Thank you so much.
All right. We have time for one more question, one last question. Do we have a question anywhere? Right here. I would also like to ask, I actually missed part of the presentation, I had to step out, but I'm wondering today, depending on my destinations, for example, if I'm going out in Dubai or in Jordan to particular locations that are restaurants or things like that, are those being transferred over into your Eats app and, or your, sorry, not Eat, well, Uber Eats now and Careem are almost the same thing, like my ordering app to kind of do recommendations on the food that I might like?
Not as of today, but I think that's on the roadmap. We started Careem now, I think, a little bit less than 6 months ago, and we're trying to prioritize the most important cases, but this is one of the cases on the roadmap.
Excellent. The last question. Yes.
Hi. I would like to ask about the fraud, detection of the frauds. You mentioned you train the system to detect the fraud. The first thing, how you found this fraud first? What is the input for you to find this fraud before you train?
Okay, so let's go to the cash underpayment example, where basically customers take trips and they don't pay for that trip. And they don't come back to the platform within, let's say, a month. We flag this, we label this as a fraud case, right? And then we look at the customer and see if this customer, how many trips they had, what was the city. We look at their email, by the way, like if the email was random or it represented a good name, the relationship between the first name and like the email. So we look at all these features and we know which trips were fraud, right? And then using this data, we train the model. So the next time the model sees a similar behavior, it can predict if this is fraud or not.
Excellent. Thank you so much, Abed, once again.
Thank you so much. Thank you.
Thanks.